Okay, can you now see my presentation?
Yep.
Yes, we can see the presentation.
Get rid of that toolbar. That. All right. Okay. Okay. All right. So I'm Dave Crosslands, and I'm the lead programs and operations manager for the Google Fonts team. And my role is focused on font development. And so this is a Google Fonts About page where you can learn more about Google Fonts. And to recap my background a little bit, I did interaction design as my undergraduate studies in London. And in that period, I attended many events about typography at the St. Bride Library. And at the St. Bride Library, it's one of the most significant collections of typography and historical printed reference in the world. And it really, my experiences there really got me hooked on typography. And yeah, this image from the British Library, is sort of a upside down globe from, a long time ago. And I love this image because it, it shows how, things have been global for typography, since when it was started. And this also kind of shows, a kind of skewed projection of the world when you see it, the kind of way we expect to see it even. And indeed, often the way we see the world is sort of, skewed. Here's a more accurate projection, where you can see Europe and Greenland are the right size. And so, typography has been kind of, European centric for a long time.
David,
and
sorry to
I learned it.
interrupt,
Please.
but I think your slides haven't advanced.
Oh no. Oh no. Oh, Zoom. Is that working now?
No, we see the map.
Okay. All right. Okay, great. Well, here we go. So yeah, that was St. Bride's. That was Ravensbourne. Here's the map upside down as it was drawn. Here it is inverted. Here's a more accurate projection. So yeah, I got really into typography because it combines these areas of visual culture, language, technology, business, and history. And something that really appealed to me is that it's ubiquitous. So yeah, I went to the University of Reading to do a postgraduate study in typeface design, and my dissertation was about the free font movement. I designed the typeface Cantorel, which, as mentioned, is used on the GNOME desktop. And so, yeah, I'm excited to talk with you today about variable fonts. So variable fonts, here's an example of the Skier typeface by famous type designer Matthew Carter in 1994. And this is a little bit of a kind of back to the future technology. So Monotype have a great blog from a few years back. They have this great image from the press in the 90s of Bill Gates arguing with John Moore, founder of Adobe, and there was this kind of period where different font formats were coming out, different platforms, fonts didn't work everywhere, and so fast forward, 25 years, and there was this announcement at the A-Type-I typography conference in 2016 that this variable fonts technology was coming back, and you've got Google, Microsoft, Apple, Adobe reps on the stage there, and the big difference from 25 years ago is that it's now this ubiquitous technology. This isn't just a technology, in search of a problem. This does bring real benefits to users, like techies. And the three kinds of benefits that I see are, that we can to compress, to express, and to finesse. And so the compression aspect, here's Google Fonts, and you can see in a family like Hepta Slab, then we have lots of styles. And on the Google Fonts page, you can see up here there's a little filter to show only variable fonts. And so if you do that, you see these families with lots of styles. And traditionally, this would be lots of different font files. With the Roboto, for example, you have this range of styles of weight and width. And as a variable font, you can kind of imagine the corners of those different weights and widths and kind of fill them in. And the file size equivalent of that is, that you get four the equivalent of 4 files, but you get all of these styles for the same file size. So the more axes, the more kinds of styles in the font, the smaller the cumulative file size. So for expression, this can be quite exciting because now you can pick exactly the weight that you want, within the range that's provided. And traditionally, you could maybe see a weight like this, and with variable fonts, you can get even more extreme kinds of styles and be expressive in what you choose. And so I've been working for the last few years with David Burlow at the Font Bureau company, he's worked on this technology 25 years ago with Apple, and he worked on 2 typefaces. The first is Decovar, which sort of really tries to show off how expressive variable fonts can be, because within this typeface there are dozens of kind of common styles, it's something that you can kind of pick and mix the different variations. And so potentially there's dozens or hundreds of styles. And on the Axis Praxis website, is a great kind of playground for variable fonts, and you can see you've got all of these different axes of variation to play with. And that's possible because David is sort of thinking about things native to the format. So you have the Adobe multiple master model here, where we have these corners that are filled in. But the Apple GX model was a bit different. It starts from the center, and then you have these interpolation masters or matrices, which you extrapolate along, and those can be combined. And so the overall range of weight and width shown here in both examples is the same, but the way it's constructed is different. And that's really what Decovar is leveraging to provide that range of different styles. It's the blending or the combining of the axes. And so to think about it in mathematical terms, these are vectors, and they're just being sort of added and subtracted from each other. And so that brings us to the third benefit, to finesse typography. And so even with a variable font with kind of only one axis of weight, you can see here, we have this Arabic kind of headline. And if we increase the weight, then the letters get wider too, and then that breaks the headline into 2 lines. If we were picking a kind of more medium weight, if we were to fine tune that weight, we could find, that by adjusting the apparent width through the weight axis, we could do some headline fitting. And so we could kind of finesse the headline so it was a medium weight, but it was just the right medium weight to fit the headline onto one line. And so perhaps the sort of most interesting axis for optical size for finessing typography is optical size. And so the other typeface that David Burlow developed a few years ago is Amstelvar. And this is really pushing the limits of how it can vary for fine text typography. So you can see here there's designs for small sizes and large sizes. Here, those designs are shown, as kind of scaled up or down to all be the same size normalized. And you can start to see the differences in the letter forms, which are size-specific designs. And so here again is, sort of a range of sizes all scaled to the same size. This animation then starts to show how these work, together in practice. You can see the way the letter forms are changing. Both scaled, fixed to the same size, so you can see what's happening, and then change. The letter forms are changing as well as the actual size is changing, so you can see the effect as it's to be experienced. So where could you obtain some of these optical size designs? Well, if you go to fonts.google.com/variable fonts, which you can kind of find through our about page, you can see you can filter for the different axes available. You can see that we have some font families available. And so one that I'll do a quick highlight on. You can also see this from the Type Foundry's website, Type Together. So this type family has quite good glyph set. It's got Latin, Greek, and Cyrillic. And it's been designed for reading ebooks on screens. and it has a broad range of weights and a range of optical sizes. And on the Foundry's webpage, they have a kind of demo site where you can kind of experience in different formats the typeface. So you can see, in dark mode, you could adjust the weight slightly to optimize it. And you can see how the optical size can be adjusted for different formats. And then at the end of the demo, they have this interactive playground where you can sort of see there's this, sort of different sizes, different weights, and how they work. In working with David Bellow, he's developed this app typetools.typenetwork.com, which is a free Libre open source web app for previewing and playing with variable fonts. And so one of the important ways to use optical size fonts is that you can see in his app, they have this little mirror size changes toggle down here, where the optical size is related to the font size and is kind of mirrored. So as you change your size, the optical size is changing automatically. And this is actually built in to CSS. There's a CSS property, font optical sizing auto, which is on by default, and that will automatically set the optical size. And this isn't a totally novel idea. I found this great email, discussing this idea of auto selecting optical sizes for a font from 2013. If you're using, variable fonts in a tech engine, I think it's well worth investigating this because it's a very powerful feature. So I want to now kind of change tacks a little bit and talk a little bit about some of the theory behind why optical size or size-specific design styles are designed. Because as a user, you have the ability to accept the automatic size selections, but you could also override them and set them, more appropriately for your document. And so the first idea I had to show you is this, idea about human perception. That the way that we read type is to do with our physiology, our neurology, and there are certain limits to this. So here's an optical illusion that's kind of fun, where it says, there are these 12 back dots, and if you look around this image, you kind of get the sense that the dot you saw disappeared. And in fact, there are no dots. It's an optical illusion where the dots are being sort of hallucinated because of the weird interplay of white and black shapes. In this example, this is actually spinning. It's not just your mind playing tricks on you. The tricks your mind are playing are those white kind of faint beams radiating out from the center that don't really exist. This example is pretty freaky. If you just stare at the middle of the page and just focus your eyes in the very middle of the page and relax, you should get the sensation that all of the sort of chaotic lines are kind of fading into a regular grid. It's very strange. So another example of how our visual perception can be played with, this is actually a black and white image, but then it has these colored lines cut through it that kind of make us hallucinate it as a full color image, which you can see if we just cut out most of the image, you can see it's a grayscale image with bands of color. And then similarly, turning back towards type and black and white, you see these two dots. The left one appears much lighter than the one on the right, but indeed they are the same gray. It's the context around them that's changing your perception. This example, goes back to movement. It is a still image, but if you look around it, especially like if you looked from one corner to another, you get this kind of shimmering effect that's a little bit kind of vertigo for me. And this indeed has been used in type design for kind of psychedelic lettering. So the point of showing you these examples is to, sort of just remind you that you can't always believe, what you see. And some of these optical effects or illusions are very relevant to type design, everyday, regular typeface design and typography. So here we can see, horizontal bars of the same length that look different lengths based on the context around them. Dots that look different sizes based on the context around them. Straight lines that look crooked. Straight lines that kind of bend and warp. yeah, lots of strange things can happen when looking at black and white shapes. And so that's a big concept for optical size design, that we can adjust the typeface to mitigate these kinds of effects as they change at different sizes. And then that raises the question about what is size. And so often viewing distance isn't fixed. Obviously, when you look at the moon, it's smaller than your finger. That's because of the difference in distance between those two things. And so when you're dealing with type and optical size, this is also an important aspect of the nature of size to be aware of, that your reading distance is going to change things. Now, this illustration is sort of where we really get into the meat of it. So you see here, this is a spatial frequency graph, and you get a sense that there's a kind of hump in the middle where the black and white bars extend up before kind of disappearing and becoming totally gray. And different people have a different kind of shape of that hump based on their own individual, biology. And if you move further or closer to the screen, you'll also kind of see that kind of hump shifting. And so in the way that this relates to type design is that these optical size adjustments in different letter forms are trying to optimize for that spatial frequency kind of tune, that like the way that your visual perception system is going to enjoy a certain spatial frequency, which is like that kind of hump that you see at the bottom here, is kind of what's happening, that we're trying to key into that as the type gets smaller or effectively further away from you. And the sort of state of the art of this, over 120 years hasn't really changed. So above we have an example from Century Gothic from American type founders from 1900, and then here we have a new typeface called Roboto Flex. And so David Berlow, the lead type designer on these projects, has this idea that these size-specific designs, it's not about designing for elegance at large sizes. It's also a legibility optimization as well as at small sizes. So I want to talk about those two things, large and small sizes. So briefly, large sizes, company logos we've often seen become, kind of nice, thick, almost monolinear sans serif designs. Lots of companies have done this kind of, rebranding in the last few years, both in the technology sector and in other marketplaces. And so part of the reason I think that that's happening, David Berlow's proposed that's happening, is because they need those brand logo types to be resilient across all kinds of environments. And so optical size variation, you can see here, at the smaller sizes, this company logo becomes less legible, less easy to read. And by moving to a sans serif design, then without any variation, it's more resilient at that small size. But with variation, it's possible to have something which is changing subtly and retaining that resilience. So here you can see, sort of the toggling between them, all those changes happening. So then for smaller sizes, how can this kind of work for improving readability? Well, readability, reading fluency is about comprehension, retention, and speed. And Dr. Bonnie Shaver-Troop introduced me to this idea that through type design and typography, we can actually affect the user's speed of reading and thereby improve their comprehension and retention. And so there's two ideas here. One is the kind of stem rhythm. In a word like minimum, then we have this fence post effect with the letter form stems, the white spaces between them. And then when we're reading along a line, our eyes are saccading. They're sort of bouncing along the letter like a pipette, kind of picking up fragments of visual material and stitching it together into our hallucinated perception of the world around us and the page, the line, the text. And so you can see that because of that saccade process, you can rearrange the letters inside a word and actually read quite reasonably, a little bit slowed down, but I can, kind of comfortably read this. Similarly, you can also, kind of flip a paragraph around, and if you try to read these second, third, fourth paragraphs, it's surprising for me, how fluently I could read these totally strange-looking paragraphs. So this idea that we could use typography to improve our reading, I think is really powerful. And there's this project Lexend that Bonnie had been driving the last few years, which is trying to allow users to adjust their typeface to improve their reading. And variable fonts is an ideal technology for this because, as you can see on this slider down here, you can adjust the typeface, making it wider, both in terms of the interletter spacing, the space between the letters, and the inside transparency, the kind of counterform spaces inside the letters. And so what you might find is, as a very fluent reader, the regular sort of hyperextension, they call it, the combination of interletter space and inner space is very comfortable, and you can read very well. But more beginner readers may find that by slowing down the speed of their saccades by making the distance longer, then they're able to kind of sync up their neurological and physical reading processes and improve their reading. So yeah, for product and page design, how can these things be work together? Well, with the Roboto Flex font I mentioned, I want to kind of focus on some of the details here. So this is the classic Roboto used at a range of different typography styles and sizes, and you kind of can get a sense that it's a little bit uneven. So with Roboto Flex, we have a fluid optical size range of styles, and this provides a much more even color across those different sizes. Here you can see kind of two up the comparison, and yeah, you can see it's a smooth continuum where the style is kind of regularized. And here's the 32-point design that's kind of misapplied to all those sizes. So you can see it looks good in the headlines and it's less comfortable in the smaller sizes. Likewise, if we take the 14-point design, that's going to improve that paragraph, but at the top, it's becoming a lot longer, even seems to be bolder. And so what we can do to kind of finesse this before variable fonts is to use the lightweight for that large size, which makes things a little bit more even. But with a variable font, with the automatic optical sizing applied, this is making the color more even. It's making things more comfortable read in the body text. It's improving the speed and comfort of reading the headlines because they're a little narrower, as well as lighter, and it's better typography. So again, here's that kind of comparison of the smoothness. And now this is just for regular. So how does this relate to other styles? Well, we originally, with Roboto, there was this very limited range of styles published. The condensed styles didn't have all of the weights, and you can see subtle, but you can see the Roboto condensed bold is slightly heavier than the regular bold. Not as much as the black weight, but slightly. So what is happening there? Well, the reason is that we have this typical font family, where all the styles from regular and italic are evened out. You get a complete set. And at this size, all of them seem to be working well. But when you start to scale them down, then the styles on the edges start to break down. They start moving out of that spatial frequency, sweet spot. And it's really those core styles which are more useful. So a way of thinking about this is a kind of upside down pyramid. And type designer DJR, David Jonathan Ross, has published this Roslindale family using interesting business models called the Font of the Month Club, where he releases one font style every month. And he's released this family, over months, style by style, and yeah, has made this great illustration. He says, what I'm sending you today, he's just sending, these styles, and there are these other sizes designed for smaller size usage with a much more limited range of weight and indeed, different widths. And so they form a kind of pyramid system where you have this greater range of weight and width, where you have more room for it. And at smaller sizes, there's just less room for the strokes to get thicker, the counterforms to get thinner. And so here's an animation of kind of what that looks like for Roboto Flex. So you can see as the size is increasing, there are these adjustments to the proportions. The X height is going down, the stroke weight is going down. So now let's see through the range of weights that with more room, we can really increase the weight. So the black weight gets really heavy. The width can get a lot wider, and the condensed style can get more condensed. And that can become quite extreme when we reduce the weight as well. So the most extreme minimum width, minimum weight design is extreme. So this obviously, allows us to have a much greater range of kind of expressive choices. But going to the text typography again, this typeface has a lot of personalities. But if we choose one of those personalities, we can still get that smooth range of typography at different sizes, even though we're no longer in the kind of regular default style. And so the way that we can do that is because of what the Font Bureau call the parametric axes system. And to really understand this, you have to look a little bit at how they design type. So these axes, there's kind of two big sets. There's the transparent axes, which are changing the spaces inside and around the glyph. And those are broken out into X and Y dimensions. And then there's the opacity axes, which are changing the stroke weights, again, split out in terms of X and Y direction. And so those four axes can be combined in various ways to create the weight width optical size axes. So you can sort of see here, we have these animations showing this step by step. So optical size is, these variations are developed by combining or blending the XTRA, X transparent, the spaces within the letters in the X dimension, the XOPQ, the stroke widths in the X dimension, and the YOPQ, the stroke widths in the Y dimension, plus changes to ascenders, descenders, and overall lowercase height. So let's kind of step through with that. In the example of Amstelbar, we start with the default design, and then when we're designing the optical size 8-point design, then these are the steps we would take. We would adjust the X dimension OPQ opaque stroke shapes. Then we would adjust the X dimension transparent shapes. And then we would adjust the lowercase, making it larger by increasing the transparency, the spaces inside the lowercase letters. And then we would increase the stroke weight also in the Y dimension, reducing the sort of stroke contrast. And that produces this optical size 8-point design. Similarly, for going to our largest 144-point design, then we would want to start with the Y dimensions stroke widths and really make those very high contrast. Then we would take the X height down, and we would further adjust, the stroke weight a little thinner, and then we would, make this big adjustment to the counterforms inside the letters, the sort of the X dimension transparency. And so with those interpolation masters, we would then get this complete range of sizes, which I showed earlier. So this is this idea, that out of the you have this fluid range of optical sizes, but as a user, you also have access to these underlying axes. So you can really fine tune the text typography. So if you, want things to be, customized, not just the defaults, you can do so. So here's a practical example, diving deeper into the X transparency, the Y transparency, the height of the kind of counterforms, the spaces inside the letters. So you can see the Y TRA axis overall is adjusting both the uppercase and lowercase heights, the ascenders and the descenders. So then there are this kind of third level of axes where you can individually address the height of the lowercase or the height of the uppercase. So a practical application of this very fine control over specific aspects of the typeface would be, when you're doing interscript matching. So here we can see, Roboto is paired with the Noto Sans Thai typeface, and you can see that, for good typography, we want the baseline aligned, but also we can adjust the design of Roboto to be a little bit taller in its ascenders to kind of nicely align and harmonize with the Thai. Now I want to struggle a bit with the Zoom app. I want to break out and show this current example of work David Burlow's leading today. It's kind of cutting edge stuff in collaboration with the developer Larsa Pfister. So I think if I click this link, can you see this now? Is it working?
Yes.
Okay, great. So you can see as I loaded this, it loaded the Wikipedia page on typography, and then it's sort of line by line adjusted the typography. And so what it's doing here is a kind of sophisticated hyphenation and justification algorithm, which is using this X transparency axis. So it's not just the width axis where there are other changes blended in. It's just purely using this X transparency axis to optimize the page. And up here on the top right, I have this little control. So I can say, some different viewports. And then I can control here, and I can pause it. And so you can see here, this is using the XTRA axis, and in addition, adjusting CSS letter spacing and word spacing properties. If I reset it and then rerun it, I think you can see again how it's improving the line justification. Okay, if I go back to the slide. Oh, no. Oh boy. No. Oh dear. What a muddle. A sec. Let me restart the screen sharing. All right. Okay. Share screen. Share the window. Share the window. All right. Okay, so where could you learn more about this? Well, David Burlow has been working on a kind of brochure to go through these, these topics of typography and these ideas like, interscript matching or better hyphenation justification. And so that's at the variablefonts.typenetwork.com site. I think there's a big opportunity to apply this to like the microtype package, and to use variable fonts to really finesse text typography in the tech typesetting engines and your documents. All right, thank you very much. Yeah, here we go. So I think we've got about 10 minutes for questions and discussions. Let me look at the chat here.
Thank you, David. And if you have questions, just join live and raise your hand or just come in.
If I may, Paolo, I have a question and a short comment. My comment is that for us techies, it's very nice to know that at least lower tech now supports variable fonts and different axes, and I think that and you can use it using current font spec with raw feature, I think, which is absolutely great. And my question is, how much more effort does it require from font designer to add axes, and how much more work is this to just not to design a font, but design a font which would have axes and would not look absolutely bad in all the combinations?
That's a great question. Well, yeah. So I think definitely. I had pointed out that the Lua tech developers have been working on variable font support, thinking about optical size for nearly a decade plus. And in fact, part of the heritage of this is in Donald Knuth's Metafont. Computer Modern has optical size variation. The original text system does this kind of optical size variation, and that is like the most difficult approach, right? Asking type designers to do real metafont programming, basically, it's extremely high bar. And the Euler project, in the AMS Euler project, they get famous project, they gave up, right? They were at Stanford, they couldn't do it, right? They went back to using Metafont to draw outlines like a PostScript font system. So yeah, this approach, of variable fonts where you still draw the outlines and then you interpolate them, gives you some of the power of the full Metafont, Computer Modern fonts, but it strikes this balance where it lowers the bar to the execution of the typeface in font technology. And while the GX model had kind of died out for 25 years and then was kind of reborn with Bedad, who was here. He's really one of the key people at driving this in the last 5-6 years, along with Adam Twardok, who another techie. I think he's the president of the Polish techies group, Gust, at the moment. And so Bedad and Adam, I think are really kind of key initiators of this effort to make variable font technology so ubiquitous. And so what happened when GX was down was that Adobe Multiple Masters was kind of up in the 90s. And at the beginning of my talk, I talked a little about my educational background. I studied at a London design college, and it was actually at that time when I was just beginning my undergraduate studies that Adobe took away the multiple master features from their applications, and I was kind of pissed. It's one of the things that kind of radicalized me about free software and learning about the tech software for typography, because it was free Libre software where no one was going to take my features away. And so that technology went into font editors, particularly the Font Lab proprietary font editor, which Adam is employed at as a product manager. And so type designers have been using interpolation pretty much for those 25 plus years. And so what we see is a lot of variable fonts with weight and width axes, because really they've been using weight and width axes in their type development for decades. And so in Font Lab or Glyphs app, or common popular font editors that have used interpolation features for design time, they just added like an export checkbox, export GX variable fonts, and then boom, right? But the reason I'm working with David Berlow is because he had this longer history with the GX model, which has this different kind of mathematical basis, which I showed, right? You start from the center and go out, you can blend things. And regrettably, there hasn't been a lot of innovation in type design applications to help designers design variable fonts kind of natively. And if you're kind of familiar with this like Marshall McLuhan ideas of media, then often what happens when a new medium is developed is it's used to mimic the previous technology, and then later you see kind of native expressions of the media. And so like in the beginning of radio, people would wear suits to announce the radio because they were used to public speaking, and television was like a camera in the middle of auditorium just recording a stage play. And then you had Citizen Kane and cinematography, and it like changed it. So I really see David Berlow as that kind of Orson Welles character here, where he's designing type kind of with like the grain of the GX technology, the variable fonts technology, and this blending is built into Decovar and Amstelvar. And one of the reasons he's working with me on these free Libra fonts, very surprising, that a font bureau would do this to some people, especially, a few years ago, is that by making these fonts and their source files available to everyone, we want to encourage more people to make fonts like this. And so the role that the tech community can have, the reason I want to present this to you today is because if we start to see people learning about this, thinking about it, and using it to produce better quality typography, then that's going to lead people to say, well, I can do this with Roboto, Flex, and Amstelvar. Now I want to do it with, say, Literata, and there's going to be this demand for type, foundries, font developers to make fonts this way. So maybe that's, a little bit quixotic, a bit ambitious, but that's really what I would like to see happen in the world. And these parametric axes, if we just use the XTRA axis for justification, well, it's not so, crazy to take an existing type design and just add that one axis for that one benefit, and then you could improve your hyphenation justification using a built-in automatic algorithm for it, like Optical Size has this automatic application. And you could see that in a lot of typefaces, and it wouldn't have the wide transparency interscript, matching with Thai or Chinese or whatever, but it would just have the XTRA for the, the justification. So Roboto, Flex, and Amstelvar are kind of, kitchen sink, everything is there, the full parametric set, and it's a bit of a tour de force, and it's not necessary for everyone to do every axis. So I really hope to see, type designers, adopting these axes. And the key to that, I think, is to start to see usage. And so that's why I'm very happy to have Roboto next generation as Roboto Flex with this stuff. And we'll see what happens.
Thank you. Thanks.
David, I have a quick question.
Please.
How is the testing done on variable fonts? Like, so suppose I have I have an X to the power of E, and the E is very small, and in that particular case using a variable font, how do I know for sure that that little hole in the little E is not gonna disappear because of the size or because of some font parameter? How is the testing happening by hand on every device, on every print, every output possible, computer?
I think, one of the things with type and typography is that, every font is kind of unique in this respect. A classic thing, right? A lot of beginner typography people would say, wait a minute, when I set the font size to 20, these two fonts look totally different, even though they have the same size.
Right.
And that's because, what is in the font is up to the font designer. And so I think it's very difficult to make broad statements about that. I think, the reason I'm passionate about free Libre open source licensing of fonts is that, if you get that problem and you write to the font designer, you say, I've got this problem, will you fix it? And they say no, then you can go and find someone else who will say yes, right? And to me, that's like very, very exciting. That's why I've spent my career working on this. And so with variable fonts, the technology, the technical complexity is increasing. So the rate at which you are likely to find that kind of problem that you've encountered that in their testing they didn't surface and fix already is also going up, right? The technology sophistication is up, the probability of bugs is up. And for me personally, the importance of having a free Libre license is up. And yeah, it just depends on the font. I think what I've seen in the tech community, which is I think kind of nice and sophisticated, is that when people like some proprietary font and it has some issues because it's been maybe say made for other systems than the tech systems, then they make some nice package that's on CTAN that like ameliorates some of those rough edges and like makes it work well in our systems. And so if there's one glyph that's wrong, potentially you can make your own font that's just got that one glyph, right? And it does the thing that you want it, and you can kind of overlay the two fonts in your font stack and fix it that way. I don't know. It's a very broad question, so I can't give an easy answer. And we're out of time. I'm sensitive to that. I think we have to move on to Matthias Roche's how to make a logo symbol for a font talk.
Thank you very much.
Which is sort of on that topic. Yeah.
Thank you very much.
All right. Thank you.
Matheus, are you there? Tá aí? So the next talk is Matheus Rocha is a part of the continuation of the workshops of yesterday, and he's going to do a brief showing of how, instead of trying to make the symbols by hand or into graphics, how can we just make a character of a font from that and quickly add to a personal font that you add in your files and use it in tech in the next minute. So let me pass over. He's going to talk in Portuguese, and I'm going to translate him over to English. Matheus, you're there? Matheus, está aí?
Estou aqui.
Vamos lá.
Boa noite.
Good night. It's night in Brazil right now.
Bem, já posso compartilhar a tela?
Sim, sim. Yes. You can just share and start anytime you want. Você pode baixar e começar.
Ok.
Deixa eu explicar para eles um bocadinho, só mais um bocadinho. He's gonna show us how to take Impas logo, which is a Möbius band, and just convert that into the letter I of a particular font so that you can use as an OTF font anywhere you want, with a few simple steps.
Ok. Você consegue ver a tela com o símbolo do ímpar?
Sim.
Ok. Bem, o propósito hoje é tentar mostrar como a gente pode pegar um símbolo já pronto ou desenhar um símbolo dentro de um software de desenvolvimento de fontes. Então,
The purpose of the talk is to just show you how you can simply take any graphics and insert in sort of a font manipulation program and create the particular character you want.
Então, o símbolo que a gente vai utilizar no teste é o mesmo símbolo da marca do IMPA, que eu já tinha aqui na minha máquina.
The symbol that's being used is the Mobius band, which is something that he uploaded to his own machine, starting from a graph that was supplied by the Institute, IMPA, which uses it as its own mark.
O software que eu utilizo para desenvolver uma fonte é o Glyphs, a versão 3, para ser mais precisa. E, ok, pode falar.
The software used here is Glyphs from the Macintosh version 3.
Assim que a gente inicia o Glyphs, a gente pode escolher uma caixa, um projeto novo, e ele já apresenta uma série de caixas onde a gente pode desenhar letras ou colocar qualquer tipo de desenho.
So as soon as you open Glyphs, it offers you the boxes for each one of the glyphs, and you can just choose any one you want and use that for your new symbol.
Então, a gente pode escolher qualquer letra dessa, aonde a gente vai colocar o símbolo que a gente quer importar para dentro de uma fonte. Então, eu vou utilizar, por exemplo, a letra A.
So I'm going to use the letter A as I could use it just about anything, and that is how I'm going to refer to the font later on, to the symbol later on.
Eu posso simplesmente importar uma imagem que esteja no computador para dentro do software.
So we're going to import the image as it is in raster format inside Glyphs.
Ok. Com o Glyphs, ele tem algumas ferramentas que permitem que eu construa vetores para definir qual que é a imagem que o símbolo vai ter. Não basta importar a foto, eu preciso transformar essa foto em um vetor.
I need to, the first step that we have here is to change the raster image into a vectorized image. So there are a few tools provided by Glyphs, and that will help me out work the vectorization of this particular raster image.
Então, com uma ferramenta de pena, o atalho P, eu posso começar a traçar esse vetor.
So I use the pen tool, which is just the letter P in the shortcut, and I start marking up the dots that make up the image, and it will help me vectorize it.
Exato. Com a tecla espaço, eu consigo separar o vetor da imagem de fundo e ver como está se tornando o vetor que a gente está desenhando.
So with the space bar, I can switch in between the vector image that's presently there and which is delineated by the vectors traced so far.
Com a ferramenta de seleção, select, eu posso manipular esses vetores e pode falar.
With select, I can with the select tool, I can pick up these vectors and manipulate them, move them, and to any place I would make a better adjustment.
Apertando a tecla Option, eu posso. Ok, one moment. Meu. One moment. Constrangedor.
Yeah.
Deixa eu iniciar de novo. Eu posso também usando a ferramenta Pen e clicar e pressionar, fazendo o detalhamento da curva do vetor.
So with a click and a press of the mouse, let me observe that he's on a Macintosh, so there's only one button, and he can adjust the tangent vector of the curve, so the better adjust the curve to the shape.
E com a ferramenta de seleção, a gente pode mexer nessas alças alças do desenho. Mas repare que a bolinha, o ponto está verde. Isso quer dizer que as alças ficam alinhadas. Pode falar.
So with the select tool, I can pick up each one of these points and take the tangent and move them up and down and to adjust better. The dot is marked there in green, and I can move it, the tangent up and down to adjust better to the shape.
E clicando 2 vezes no ponto, eu consigo, ele passa de verde para azul e me permite manipular essas alças independentemente.
With a double click, I separate the two tangents at that point, and it allows me to manipulate them independently. The one on the left and the one on the right of the point. And that's what I'm doing now. This is the operation. I'm releasing the connection between the two parts of the tangent and moving them independently. And the dot at that particular point changed from green to blue when the two vectors are independent. And then you can see it's fairly close to the shape that we desire.
Bem, para a gente não perder muito tempo, eu mostrei eu preparei como que ficaria aproximadamente esse vetor.
So after you vectorize the whole thing, he's just like one of those master chefs cook shows. He has the plate ready, and so after you vectorize the whole thing, you have this image that you see now with the dots. So there are 4 parts to vectorize in this particular graphics.
Uma vez que o vetor esteja pronto, a gente pode simplesmente exportar. Antes disso, a gente nomeia a fonte, Command I, a gente tem esses parâmetros da fonte e a gente pode escolher um nome. Por exemplo, Impalogo. Quer falar?
Yeah, so right now, with it vectorized, I'm going to straight export it to the font. I'm already naming the font, which I'm going to name it Impalogo, and proceed for the export.
Command E para exportar. Aqui tem os vários tipos de formatos que a fonte permite ser exportada. Então tem o OTE, OpenType Font, Variable Font, UF, e a gente vai exportar em OpenType File, OpenType File, sorry.
So the export now is going to happen in an OpenType format. You can choose several different formats you want. Easiest one of them these days is OpenType.
A gente segue, ele te pergunta onde você vai querer salvar. Vamos salvar na área de trabalho. Na nossa área de trabalho já está aqui, Impalogo regular. E se nós colocarmos a gente só precisa de instalar a fonte no nosso sistema para poder utilizar o símbolo livremente.
So what happens there? You just save the character, to the font now named Impalogo, and you have an OTF file that you can double click to install and start using the next minute.
Ok, repara, já está instalada. Eu vou abrir um arquivo branco aqui no Illustrator.
So it's installed. I'm now opening Illustrator, and then we have a letter A, and if I choose the font,
O nosso símbolo já está sendo utilizado.
and the symbol is ready, and it's ready to be used in any way you want. Muito
Ok.
obrigado. Thank you very much. This is a skill that we all should acquire, and to be able to do our work. É uma tarefa que a gente devia saber fazer em qualquer situação.
É muito útil. Hoje a gente tem vários designers que utilizam esse tipo de método em vários programas. Já vi pessoas otimizando muitos processos, como sinalização e editorial, inserindo símbolos dessa forma.
He's saying that this is a process which is extremely used within design these days, to escape out to a font immediately because of the facility of the tools provided by the programs like glyphs, and the reutilization that once you do it in one particular situation, you can very easily reutilize in several other different situations. Any questions? Anyone? So a Uwe Hagen está dizendo que vai ser muito bom um dia ver isso usando software livre.
Concordo.
Uwe is just answering to you that he agrees completely.
Falou comigo, Paulo?
Não, eu traduzi para ela a sua resposta. Deixa eu ler o chat aqui. Ok. Ela está te dando um sinal de joia. E a Jennifer está dizendo muitíssimo obrigado. Muitíssimo obrigado. Foi
Obrigado.
Uma ótima, uma beleza de palestra. Thank you very much.
Boa noite a todos. Obrigado pela atenção.
Thank you. Now we're moving over to the schedule, and we're going to have like a sort of a brief intermission, and have a talk by Oliver Austin in about 25 minutes, I believe. 25 minutes. Matheus, tem algumas coisas no chat para você.
Sim, Paulo.
Tem algumas coisas no chat. Tem a Jennifer dizendo, te elogiando.
Obrigado. É um prazer poder contribuir.
Beleza.
Ah,
Você viu?
uma, uma coisa que eu não disse, mas que é relevante, é que você pode importar um vetor feito em qualquer programa qualquer não, mas a maioria dos programas vetoriais. Então, você poderia fazer o desenho no, no Illustrator, no Inkscape, e trazer para dentro do Glyphs, só para fechar o programa, fechar o arquivo de fonte.
So what he's saying is that the vectorization itself can be done in just about anywhere, including by hand, and then be brought into glyphs. With literally a drag and drop, and and then glyphs will sort of do the wrapping to save it as a font. But this particular vectorization glyphs can take the vectorization from just about anywhere. Beleza, meu. Muitíssimo obrigado, cara. Foi muito boa a palestra.
À disposição.
Legal. Hi, Oliver. You there?
Hello, yeah. Okay. Is everything working?
Yes. Let me make a brief
Okay.
introduction, and then you can jump in.
Okay.
Our next talk is Oliver, and he's a student at Oak Grove High School in San Jose, California, with a passion for aeronautics, and he's going to talk to us about typography being used in runways and in other settings. Thank you very much, Oliver. Have the floor.
Okay, thank you. Let's see if I can get my presentation shared. Okay, everything, can everybody see everything?
Yes.
Okay, so as Paul said, my name is Oliver Austin, and the presentation that I am going to be doing is an exploration on machine interaction with text type for visual-based navigation systems in aviation. So a bit about me. Like Paulo said, I'm a high school at Oak Grove High School. I'm going to be graduating in 2022. I'm also the co-president and co-founder of Oak Grove's Makerspace. And I'm also a student pilot taking lessons at Sundance Flying Club in Palo Alto, California. So an introduction to the project I've been working on. Visual-based navigation systems usually consist of one or more cameras coupled with a computer. The use of cameras in these navigation systems usually allow for high levels of precision when controlling vehicles, leading to improved safety and just improved accuracy overall. Today, in the broader industry, you see these being used in autonomous cars, such as Tesla's automobiles, where they've just recently transitioned to using fully camera-based autonomous control for driving. On the aviation side, the aviation industry is focusing more on the commercialization of autonomous unmanned aerial vehicles, or drones. And these are going to be integrated into the airspace fairly soon. And of course, we want these to be able to navigate and fly safely. And in the most critical stages of flight, which are takeoff and landing, we want these systems to be as accurate as possible. And this is where vision-based navigation systems can become very useful. Looking at the current industry applications, Airbus is one of the leaders in these visual-based navigation systems and autonomous aerospace vehicles in general. They have an autonomous taxi takeoff and landing program, or ATOL, which is trying to create the first fully autonomous commercial airliner that can transport passengers. They're also working on developing a UAV or helicopter that is, again, autonomous and going to be put into use in the French military or French Navy by the end of 2021. So from all this, I decided, and because this is a typography conference, I decided to create a driving question for this presentation, which is the current font used for runway designators suitable for visual-based navigation systems in autonomous aerial vehicles? In order to start to answer that question, first off, we need to take a closer look at runway designators. So runway designators are these combination of numbers and letters that are usually found at the beginning and ends of all runways. They give the runways a unique code corresponding to the runway's magnetic heading. So for example, if the runway has a heading of 194 degrees magnetic north, that then gets rounded down to 190 and then gets simplified. The third character gets cut off for simplicity's sake, and it turns into runway 19er. The letters, on the other hand, distinguish between parallel runways. So in the case that there's more than one runway which has the same heading, these letters will be used to tell them apart. As you can see in the background image, we have a runway 30 left and 30 right because they both align with 300 degrees. Looking more closely at the fonts, we can see the fonts is highly geometric. It actually has no name. So for the remainder of this presentation, I will be referring to it as the ICAO font for the sake of simplicity. But we can see it's highly geometric, and its main purpose of being geometric is so then groundskeepers can easily recreate them who don't usually have typographic training. And like I said, this is made by the ICAO font, or ICAO, which is the International Civil Aviation Organization, which is why I'm going to be referring to it as the ICAO font. So before I looked at starting the project, I wanted to first identify some problematic characteristics when using machine learning and visual-based navigation systems looking at these fonts. And I came up with three major problems. The first one is that the number 1 in this font is very similar to other straight lines that can be found on the runways, which may lead to mix-ups. The second thing is that the numbers 6 and 9 are exactly the same. They're just flipped over, meaning that if in the case that you're looking at the numbers upside down, the characters can get easily mixed up. The third thing is that in the case that there are tire marks on top of these numbers, which in many cases there are, they could make the characters 3 or 5 look very similar to an 8, which again, all these things would not be suitable if you want to have a safe and reliable operation from these vehicles. So first, let's take a look at combining typography with machine learning. In order to do that, we need to take a look at how machine learning works. It uses 3 major steps. First step is collect data sets for training a model. Step 2 is training that model. And then step 3 is using the model to interact with new data. So the model is a file that has been trained using the data sets to recognize certain types of patterns. This is the fundamentals of how machine learning works and deep learning works. And you train this model over the set of data, which provides it algorithms that it can then use to sort the new data. So step 1, it's collecting data sets. So in my case, I chose to use 2 separate data sets. First off, I wanted to look at the relationship of the ICAO font with other fonts in I wanted to look at the relation between those fonts. The second one is I wanted to see the real world applicability with the ICAO font on actual runways with other things around them. As you can see in the multi-font data set, I had 31 different fonts. And the key thing is the classes are 0 through 9, L, C, and R. The classes are what is used to distinguish which image corresponds to which item. So for example, a 0 would be in class 0 because it's 0 and so on. And I made sure, like I said, to include the ICAO font. The real world data set consists of 137 uncropped images, which then got cropped down to 143 cropped characters, and it has the same classes. So step 2, training the model. First, we start off with the data set, which then is fed into a machine learning algorithm. In the case of my project, I used PyTorch, which is fairly lightweight, fairly simple to use, and has a lot of documentation. This then creates that algorithm that can then be used later on by the Onyx model once it's exported to interact with the new data sets. As you can see here, it's kind of the same thing. That Onyx model then interacts with the new data sets, and that's where we get our prediction of new data and the confidence percentage. Confidence percentage is how confident the algorithm is that it's gotten the answer correct. So looking at my project in particular, I had 2 options for categorizing the characters in the images. I have classification and I could have detection and object localization. The major differences between these two are that classification only predicts the class of one item in an image, which limits its usability, but that labels the image with the predicted class and the confidence percentage. Detection and object localization, on the other hand, identifies the location of one or more items in an image and is able to draw a bounding box around the found items and label that bounding box with, again, the class and confidence percentages. So looking at the multi-font data set, I used the classification method for this because there's only one character per image, which seems sensible to use. And as you can see, depicted by the orange line, the ICAO font significantly underperforms relative to the majority of the other fonts. The majority of other fonts are upwards in the 90% confidence range, whereas the ICAO font doesn't even pass 60 or 70%. Taking a closer look at the individual percentages and comparing the ICAO font to the highest performing font, you can see there was improvements in the ICAO fonts, but the percentages are very low still. The lowest percentage in the last one is around 24%, which is very low for being used in like an industrial application. Whereas the highest performing fonts is all upwards of 90 and upwards of 95 even, which is really good. Now, turning to the real world data set, this significantly underperformed from where I thought it would. I thought it would perform really badly. It performed even worse. I used the classification method, so then, because that was what was easiest to use and most accessible to me. And that's why I cropped down to individual characters. And as you can see by the average confidence percentage, both of those figures do not meet the minimum of around 80% accuracy to be considered usable in a system. And this 80% is what allows us to say this system is safe to be put into operation without having to worry about it failing. In this case, this is going to fail majority of the time. It's not safe to use. The second trial is double the length of time to train it, but noted here, I put that even though it was trained longer, it's not significant enough to say that it will continue to improve when trained for even longer. So looking at that, how do we improve those results? The first way is we could potentially change the font. And as you can see, I have the ICAO font here and side by side with the highest performing font, which turned out to be Illumi in our data set. As you can see, there's quite stark differences between these two, although they do share similarities. These two characters, the 0 and the 6, were actually one of the lower performing ones in the ICAO font, and I think also in the Illumi font, which leads to other questions about maybe it's not the font itself, but how the characters are recognized. So some improvements you can make is round out some of the corners and make the characters more different than each other. And there's just a lot more that you could do to improve these. On the other hand, the more practical approach, with me being a high school student, there's no way that I'm going to be able to convince an international organization to change their font in order to make things safer. So taking a more practical approach, the first thing I can do is potentially collect a larger data set. My initial data set consisted of 11 images in the real world per class. So that equated to about 143 images overall, which is way too few to train a decent model on. The places I was limited were that I could not find enough images to train the model on Google. And so I'd have to do more experimentation out in the real world, taking the photos myself in order to increase that dataset size. The second option is training the model for longer. By training the model for longer, it gets used to the algorithm, or it gets used to the patterns in the images, and it's able to refine that algorithm over time. Although that won't work in the cases like with a small data set, where it has a very finite number of images it can base its references on, and just eventually won't yield any significant results. The third option is to use a better machine learning algorithm, but that is limited by the processing power of the GPU, and it comes at the cost of increased training time and power consumption. And that's kind of the reason behind why I chose PyTorch as my training algorithm, because it's very light and it could be done on a very low power GPU that could be implemented into these unmanned aerial vehicles. So before I finish my presentation, I do want to acknowledge some people. I want to acknowledge my mentor, Ms. Jennifer Claudio, who introduced me to the Tech User Group and helped me with all the conferencing stuff. I also want to thank the research assistants who originally helped me crop the initial multi-character data set, because that was like 400 odd images that I had to crop. I cropped some of them, but it was way too much to get the project started in a reasonable amount of time. So great thanks to them. So yeah, thank you for listening, and I will be here if anybody has any questions about what I've talked about. So.
I do have a question, Oliver.
Yeah.
How is the knowledge and the shape of this font passed around the world?
Can you repeat that?
How is this font passed around the world? The font that's used for runways. How's it
the best around the world?
Yeah, I mean, you say there's not even a name.
Okay.
How does it get reproduced?
So it was set in place by the international or the ICAO, and their main goal was making sure that it can be reproduced easily for those groundkeepers who were painting the numbers, and so then they didn't need to give them typographic training to create more elaborate characters. So it's very boxy, very simplified. You can easily mark it out on the runway and get it done very quickly. And so it was implemented by them as a standard. Just that's how it happened.
So they give just the vertices and let them fill it in with straight lines.
Yeah, pretty much. Yeah.
Okay.
Boris, you have your hand up.
Yeah, very interesting work, and thank you very much. With the ICAO books are really very boring to read, so I applaud that you found this font there. I have a question. You found where machines make mistakes in recognizing with digits and letters. I wonder whether people would make the same mistakes with the same letters. You can probably, there are in the literature, people do it. They demonstrate a letter for a short time and ask people to tell what is letter, and you probably can recruit the high school students to do it. They're very good experimental audience. It would be very interesting to repeat this experiment with humans and see whether humans perform the same or better, and whether the most mixed characters are the same. It would be a very interesting addition to this research.
Yeah, so yeah, I've discussed that a bit. The problem is finding the people and getting people to want to participate in the research, which in some cases it's easy, some cases it's not. But that's definitely a way that this project could expand, for sure. So.
Yeah. I would suggest taking your classmates in school.
I guess, yeah.
Okay, but very good, very interesting research.
Thank you.
Oliver, you have a question from Jeremy Just, asking if you have tried OCR-A and OCR-B in your tests. Do you know these two fonts?
No, I don't know those fonts, but yeah, so I haven't included them in my set, but I assumed that because you're asking about that, they could produce some interesting results in comparison to it. But I'll definitely take a look into that.
Yeah, it's the fonts are called OCR-A and OCR-B. Okay. And there are two fonts which they're sold right now by Adobe, and they have been created for studies in optical character recognition back in the 60s. And you see them all over the place. Once you see them, you will start identifying, oh, this is OCR-A, this is OCR-B.
Okay, yeah.
You start seeing the world with a new lens.
Yeah, yeah, okay. I'll definitely take a look into that, and I'll see how that can help the project.
So the other question is from Paul Danese. Thanks for the fascinating talk. I may have heard incorrectly, but it seemed like the size of your training set was quite small, about 100 to 200. Can you automate the interrogation of Google Maps to get more data, for example, runways? Also, have pilots made errors misreading skid marks on 3 and 5?
Okay, so to answer the first part of the question, yeah, my data set is quite small because I was limited by Google Images. The use of Google Maps, I have thought about that to broaden my data set, although my concern with that is that it's not going to be the same as actually using pictures from planes landing, because with Google Maps, that is an ideal situation. You have a high resolution image with a top-down angle, and of course you can rotate the globe a tiny bit to get an angled approach, but I don't see that as good enough to use in the training data set, because you need to train for those scenarios where you need to train for the worst case scenarios. If you train for the best case scenarios, it's not going to work most of the time, because most of the time things aren't the best case scenarios. As for automating it, yeah, you probably could. That would be quite a bit of work considering how many runways, and you'd probably be able to use keywords and find stuff, but that's out of my realm of knowledge.
Mhm.
And then the misreading part, I haven't heard of pilots making mistakes. And one of the things with going back to a question that was asked before about making mistakes between it and how people and machines could make mistakes, one of the things that the pilot has to assist them is they already know which runway they're going to be landing on. So they know which characters to expect. And they usually have maps of the airport as well when coming into approach. And of course, you can add that into the knowledge base of the machine, but then that takes up memory, it takes up space, and it takes up processing power to also access that. So if you're trying to make a lightweight system, then it's best to try and look at the characters and look at the runway and not reference any outside sources. So.
All right. How could you use Google Maps satellite photos to create your training set?
Okay, so that's similar to what I just answered, but
Yeah.
you could probably, the way I would go about it is I just probably take screenshots, because you can rotate Google Maps or Google Earth, so then you can have like a 3D view. I rotate that and then zoom in and have it at different distances away from the runway. So I have the different resolutions of the characters and different sizes of the characters. And also go around in from varying degrees of approach. So in some cases, you're not approaching the runway straight on all the way in. In some cases, you're turning into the runway. And so it needs to be able to read it from that angle. So I'd go around, pretty much do a 360 view of those characters, which would take up a lot of space. You'd have thousands upon thousands of images. But that's one way that you can add it to the training set and actually make it a lot more reliable.
Well, thank you for your talk. That was really interesting.
Thank you.
Very good. Now we're going to have next talk by Vafa Kaligi on Persian typesetting tech, past, present, and future. And that's going to be in about almost an hour from now, 50 minutes from now. And an announcement from Jennifer to continue the conversation from these segments. Remember that we have 2 platforms available in tandem with Zoom to allow more collaborative experience. I mean, this is Topia and Zulip. You can get the links either on the chat or on the top of the schedule page, and meet your speakers and meet your friends and collaborators there. Topia allows you to talk in video face-to-face, and Zulip allows you to carry the conversation even after the conference has finished.
Oh, now it goes. My, no, there's nothing in there. But it must be what? Now that I have given permission, there's no problem. So the first including
system. The default numbering system is Arabic. You can change this by doing a renew command and telling it the section and then telling it what numbering system you wish. So in this sense, I'm using Roman. It will stay that way throughout the paper unless you change it to Arabic or a different numbering system. You can also change margins and spacing to fit your needs. So in this case,
Jennifer.
Hey, Paula, did you just say my name?
Yes. I just was going to tell you that Topia is much, 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 much better than the stuff that we used last year. Do you see the difference?
Sorry, I think I ran away from you.
Did you hear what I said back?
Yeah. I was starting to respond and then I muted the wrong one. So I muted the Zoom. Oh, by the way, your Zoom isn't muted.
Oh, yes.
Hello, Vafa. Would you like to do a quick sound check?
Hello. I think I will start on time, about 4 minutes.
Sounds good, and I can hear you.
You cannot hear me?
No, I can hear you.
Okay, that's fine. Thank you.
Yes.
Okay, let's get started.
Hi, our next speaker, Vafa Kaligi, will talk about Persian typesetting, past, present, and future. You have the floor.
Thank you. I'm just trying to share my screen, so please bear with me.
I see that you are very close to me.
I am?
Yes, by the Golden Gate Bridge.
Can you see my screen now?
Not yet.
Not yet.
Yet.
Yes, we can see it now.
Okay, good. Hello, everyone, and thank you so much for giving me an opportunity to talk about my tech work here. This is actually a soft talk, it's not too technical, and I was hoping that the other talk, which is about the BD package, I was hoping that I would be giving that talk first and this one next, but I had to change a lot of things, so I had to cut down a fair amount of material, but I hope that's going to be okay. And if you're wondering about this logo, this actually is the logo of the package, and it actually symbolizes the Sassanid kingdom, which ruled Iran about 2,000 years ago. So I just want to give an overview of what I'm going to do today. I'll first talk about Persian typesetting and what I mean by Persian typesetting and its requirements. Then I'll talk about the tech-based solutions. Then we will talk about the C Persian package and its history. Then we will see the main features of the Z Persian package. We will also look at the challenges that we faced in the development of the Z Persian package due to the engine that it uses. We also compare it with other tech-based packages and typesetting systems. I will also tell you where the Z Persian package is used and what is used for. I will show you some examples, and we will also finally look at the current state of the package and plans for future development. So what I mean by Persian typesetting is that I want to typeset a document which is mainly written right to left. It's not just that I want to typeset a short piece of text in Persian, but an entire document in Persian. You should be able to typeset Latin text in line in Persian mode. You should also have the ability to write paragraph in left-right mode and also write Persian text in line and in paragraph mode inside Latin mode. So it's actually a mixture of those two modes. The font also should be changed automatically in Persian and Latin modes. The digits in text and math mode should appear in Persian, and the user should have the ability to change and switch between Persian and Latin digits in math mode. The indexes, glossaries, etc. should be sorted using Persian alphabets. We want to be able to typeset footnotes, of course. The Persian footnotes should appear from right to left, and the Latin footnotes should appear from left to right. And we also need to have automatic footnote rule. So if the first footnote on a page is a Persian one, the footnote rule on that page should appear right to left. And if it's Latin, it should be left to right. We should also be able to typeset the current date in Iranian calendar. For example, if you're using the control sequence today, you should be able to have the current date of today in Iranian calendar. You can also use a lot of drawing packages like TIGs and PS3s, and you want to be able to typeset the labels in Persian. You want to typeset the tables in Persian and from right to left. You should be able to choose the font for typesetting main Persian text, Latin text, digit in text, and math modes. The package should provide various counters in Persian, and the components of the different parts of your document should have Persian labels like table of contents. And the decimal separator in math mode should appear in Persian. And most importantly, the package should be compatible with almost all commonly used packages. So for example, if you want to use a multi-call, you should be able to use it for Persian typesetting. And these are not all the requirements. I just listed the very main ones that I need to concentrate on. Okay, so now let's look at some local tech-based solutions. We have Riyazi-Negar, which is translated literally as math writer. It was developed by Masumyan in 1991, and it's based on LaTeX 2.09. We also had typography developed by Dada Kavi Iran Company and Ahmadi Yazipur. In the same year, we had Farsi Tech, which was a product of the software engineering students at Sharif University of Technology. We had Iran Tech developed by Mogaddam and Shojais in 2006. And finally, Z-Persian was initially developed by Mustafa Wahedi and Mehdi Omidali, and later I took the development in 2008, and I will talk about this in a bit. It's actively maintained. It's based on the current LaTeX version, works under ZTech. It supports almost all commonly used packages and offers a rich set of features. It supports around 120 mostly used packages. Those two text systems that had a lot of influence on Z-Persian are TechParsi and Farsi Tech, and we've been using components from both of these typesetting systems and packages. What I want to convey is that we are building on the work of other people that have already worked on this area, and the end result is not just the product of one person. A lot of people contributed to the package. What is under development is a package Persian LaTeX. It's not actually a package, but a format. What it does is that it loads the LaTeX format under the LaTeX engine. Then it does some changes to LaTeX. It actually modifies use packages and loading class files. So whenever a package is used, the patches from the Persian LaTeX package is loaded. There are also other packages like Arabic, ArabTech, ArabZTech, Polyglossia, Babel, etc., and other formats like Context that allows you to typeset Persian, but they're not at the level of local solutions. By that, I mean that they are not heavily tested, they are not stable enough, and they are not used actually for practical use. It took Z-Persian about 10 years to become widely used, and this talk is primarily about Z-Persian package. So we want to talk about the history of Z-Persian. In 2007, a friend of mine, Mustafa Wahedi, published an elementary set of macros based on Arab ZTech under the file Farsi ZTech, and it was published on his blog, which I put the address there. It actually exists for historical reasons. Then later, Mehdi Omidali developed the same file further, but it was also using Arab ZTech package. And the draft version of the not so short introduction to LaTeX was typeset by that same file. I took over the development in 2008. I removed the use of the Arab ZTech package entirely and published the resulting package under the name Z-Persian on CTA. Final version of Omidali's translation of the not so short introduction to LaTeX was typeset by the Z-Persian package. In fact, several other updates of the translation have been using the Z-Persian package. The package is actively maintained since 2008, except a short period of time, which due to health complication, I asked David and the LaTeX team to maintain it, and they kindly and generously accepted, and I'm grateful to each of those people. Okay, so let's look at what Z-Persian is. If you don't know what Z-Persian is, or you haven't done any sort of Persian typesetting, it's a package for typesetting Persian documents in LaTeX. It is powered by the BD package. Actually, the BD package powers a lot of other packages, which I'm going to talk about that package tomorrow as well. It allows, as I said, it allows to use more than 100 commonly used packages and classes. I'm not a user of the package. I'm a plain text user. The package should be loaded last because it actually patches a lot of packages. So we need to make sure that it's the last loaded package. My role as a developer is that I receive bug reports, I fix them, I answer user questions, and then release the new versions on CTAM. The Z-Persian package is widely used in Iran and elsewhere for typesetting documents. It's not a perfect solution, so I'm not going to claim that it's the perfect solution, but actually it does the job, and people can typeset their documents. What drives development is the need of the Persian tech community, so they ask for features or they ask for certain bugs to be fixed, and then that's what makes the development going on. So the basic usage of the package is quite easy. You just load a LaTeX document you have. The only difference is that you have to load the package Z-Persian with its options, which is optional. And then the only compulsory control sequence that you need to use is the control sequence set text font. This allows you to actually use the font for the main Persian text. So to get a PDF, you run Z-LaTeX on the text file and you get your PDF. So I want to talk about some of the main features. Obviously, I'm not going to talk about all the features because that quite takes a lot of time. I want first to talk about typesetting digits. So when you typeset digits, you actually want to typeset the digits in text mode. You want to choose a font, and the control sequence set text digit font allows you to choose a font for the digits in text mode. The font of the digits in math mode can be typeset by set math digit font, and if you want to typeset both digits in text and math mode by one control sequence, you can use set digit font. There are also options for switching between Persian and Latin digits in inline and display math modes. There are both options and control sequences. I'm just basically going to talk about the options. So there are three options. There is math digits, inline math digits, and display math digits. And each of these has three values: automatic, default, Persian. Inline math digits means that we want to typeset digits in the inline math mode, display math mode for display math mode, and math digits means both in inline and display math mode. So when we say automatic, we should have Persian digits in Persian mode and Latin digits in Latin mode. Default, which means we should have Latin digits everywhere, and Persian means Persian everywhere. If a font is not chosen for the digits in math mode, then Latin mother fonts will be used to typeset, and in text mode, the current font is used. Now, the package also provides some global font size and baseline skip. The option math font size scale allows you to scale the font size scale of the document. So for example, if you want to scale the math font in your document by a factor of 2, you just give an integer of 2 to this option. You can also use the font size scale, which scales the font size in text mode and in math mode. You can also use the option font size. it actually accepts two arguments. One of them is the font size, and the other one is the baseline skip. The Latin font size scale can be changed by the option Latin font size scale. Sometimes you want to be able to have different font sizes in Persian mode and Latin mode. That's why this option exists. And also, there is in LaTeX, there's a baseline stretch command that you can actually redefine. This option, baseline skip, is just a wrapper for baseline stretch. And there's also Latin baseline skip scale, which changes the baseline skip in Latin mode. Finally, there's also an option called compute auto ilk, which calculates a suitable baseline skip. What it does, it actually tests the current font with some characters, and if the height plus depth of any character is greater than the baseline skip, then it changes the baseline skip to that height plus the depth, so there's no problem. We also have localized the package, so you can use a lot of control sequences in Persian as well as in English. Most of the commonly used commands are localized. All of the tech primitives are localized, so you can actually program in tech. Some commonly used environments are localized. We had to take a special care in localizing the verbatim environment, and the verbatim package, which also provides another variant of the verbatim environment. This feature is not on by default, so if you want to use this, you have to use the localized option. Text messages cannot be localized. For that, we need to actually modify the engine, which is not possible at a macro level, but we can modify and translate LaTeX messages, but this hasn't been done yet. Some color names provided by the color and Xcolor packages are also localized, like gray, yellow, red, etc. And when we implement the localized option, we have to make the ZWNG, which stands for zero width non-joiner, as a letter. So we have to give it category 11 because we want to use it as part of a control sequence in Persian. For indexes, glossaries, and bibliography, for indexes and glossaries, we use Zindi. There are 3 variants for Persian in Zindi: variant 1, variant 2, and variant 3. These are basically the same thing, but they are different based on the very first letter of the Persian alphabet. These 3 variants also allows sorting using English alphabet. There are also packages for BibTeX. There's Persian Bib package by Mahmoud Amin Tusi, and the Alpha Persian by Shapur Madadpur. Sadly, BibLaTeX is not yet supported. Okay, so let's talk about the challenges that we faced and we still face. Z-Persian is based on ZTech, which is based on ETech, which is based on the bidirectional model of TechZ. This means a number of issues and limitation. What seats are reversed. As a result, special pairs are reversed. So that means that the color actually can go wrong. We can somehow fix some of these, and actually the BD package tries its best to fix some of these, but this fix is actually very limited. For example, you can only fix the color if the color stays on one line. If it breaks on several lines, then the color goes wrong. The same thing also is true for HyperF, drawing packages, and any other thing that uses a special in a way or another. The author of ETech, Peter, was really willing. So when I talked to him about these issues, he was willing to fix it, and I actually tried to fix it, but it's very sad that he passed away. Also, there is no primitive for changing the direction of H-align. So the only trick that we have to use is that we have to put H-align or tabula in LaTeX, inside an hbox and surround that hbox by the primitive begin R and end R. That's the only way that we can make a H-align and tables right to left. And this also has another side effect. So what it does reverse a lot of things. It reverses indentation, it reverses the ragged right and ragged left. So a lot of care needs to be taken in that area as well. Also, this complicates a lot of things for typesetting line tables, like the package line table, because there is no primitive for typesetting tables right to left. And because of the limitations of TechSeed, a lot of patches is needed. So in TechSeed, we only have 4 primitives. There are 4 primitives for typesetting right to left documents. There is begin L, end L, there is begin R and end R. And there's also another one for typesetting the equation number based on the direction of the document. I think it's called pre-display direction, which accepts an integer. So let's talk about who does use the Z version package. The Z version package is used widely in Iranian universities for typesetting thesis books. It is also used by Iranian Mathematical Society for its various publications. Any annual Iranian mathematics conferences requires paper submission to be in Z Persian format. Several Iranian universities offer courses in mathematical writing, and they use the Z Persian package to actually teach the mathematical writing courses. Each university has developed a class for typesetting thesis by the specifications of their university. And a lot of publishers also use Z Persian for typesetting books. It's also used in Afghanistan, which they speak the same language as us. It's used in Kurdistan. By Kurdistan, I mean the Kurdistan in Iraq and some other places, but they use some modifications. Although in Tajikistan, they speak the same language as us, they don't use the Arabic script, they use Cyrillic script, so therefore they cannot use this package. So finally, I want to show you some example documents that are typeset by Z Persian. So I basically took this example from the textbook. I think this appears somewhere in the textbook, but it's the other way around. So instead of left, you have this thing on the left, and I just replace some text. Okay. This is a table which is typeset from right to left with some mathematics in it. As you can see, the digits in math mode appear in Persian mode. And this is the caption of the table. And everything needs to be typeset right to left, except math, which needs to be typeset from left to right. In this example, we just used the first letter. This is used in English, but not a lot used in Persian. But I thought that I would just demonstrate how this is used using the Z Persian package. This is another example using the PS3 package for calculating the volumes. So this means R out, and this is R in. Okay. This is another example where the caption of the figure is actually typeset in the margin. This is based on a modification of the Tofte package, which is developed under BD Tofte with a lot of modifications. This is another example of a table in color using the color TBL package. This is done using the same package. an example of typesetting matrices. This basically is a 12 by 5 matrix, and all the digits are in Persian. So this is a text box for typesetting Ethereum, and this is also taken from MFEC package, which we typeset mat. This is done using ticks for typesetting text inside boxes, and because the Persian package modifies and supports a lot of packages, you can actually use a lot of packages to typeset anything you like. This example is also taken from the ticks package. It tells you the different areas of computer science. The Z Persian package via the BD package also allows you to typeset footnotes in paragraph mode. So this footnote is actually typeset in mini page, and the footnotes are in paragraph mode. It also allows you to typeset footnotes in multi-columns. So the footnote at the bottom is typeset in 4 columns. I think that's all that I wanted to talk about. Thank you so much.
Vafa, I have a question. Do you have a second or so?
Sorry. Yes, I do.
I have a question. It's completely from a layman. I know exactly nothing about typesetting in Persian. Are you able? Is it accustomed to do sort of a full book in Nastaliq or not?
A full book in
Nastaliq, in Persian calligraphy.
Okay, I think I basically moved out of Iran when I was a teenager. So to tell you the truth, if I want to answer your question, my answer wouldn't be very authentic. I'm just going to tell you what I think. So it might not be the case. But what I think is that Nastaliq is actually used for typesetting, mostly for typesetting poems, and it's not used to typeset an entire book with that font, but it's used a lot in handwriting.
Okay. All right. Thank you. Thank you. Thank you for a wonderful talk.
All right.
Absolutely.
Thank you so much.
We hope to see you again tomorrow, I guess, isn't it?
Yeah, sure.
Yeah.
At 11 Sydney time.
Yeah. Well, we are having a small interval now, and wait for the interview with Norbert Preining in a few minutes. Good morning, Norbert.
Morning.
Are you awake? Did you take your coffee already?
Yes, and actually you see my cup.
Oh my God. The eternal Bahotech.
Yes.
Yeah.
I still have 2 cups of those, so I'm quite happy.
Oh, good times, good times. How are you? You ready for having a conversation?
I am completely fine, ready.
Cool.
I think most others are asleep, right?
Yeah, well, the Europeans probably. I see Jersey here and I see a few other guys, Herbert Schulz, and so there's a few European up. Well, I mean, I'm not even going to spend the time introducing Norbert because most of the people in here know him way more than I do. And for the ones that don't know him and don't are seeing here for the first time, he's a mathematician, a logician specifically, and an accomplished programmer with manifold interests. And like to talk to him about a few things because this guy has many hats, including Tech Live. If there is a manager of Tech Live, he's probably the one.
No, it's Carl, not me.
Well, but Carl has so far refused to
yes.
for an interview. So, what I would like to do, Norbert, is start out when where that other interview that you gave to TUG stopped, and
that's a long time ago.
Yes. And I'd like to tell us what brought you to do this trip to the Far East. It's a trip that's in the reverse order of most scientists, which come from Asia.
There are a lot of scientists in Japan. They get a lot of Nobel Prizes. I wouldn't say there are no scientists here.
From Europe and from the US?
I think it's on the same level. You can.
Same level?
Yes.
Oh, so, that's interesting. So what brought you specifically for to do this?
That was back 2008 or something. Actually, I was thinking about leaving academics completely and working full-time as a mountain guide because I'm also a professional mountain guide. And at that time, Professor Ono from the JAIST here, close by where I live, invited me to come over and work as associate professor there. And that was, of course, tempting. I mean, in Austria, that was always, or in Italy, you always have every 2 to 3 years, you have to write project applications to fund your own salary and all this kind of stuff. So, and that's the reason I thought, I work as mountain guide, it's easier. And then, the option to go to Japan, at least for a few years, that was interesting, yes. And of course, I thought a lot. I wasn't that young back then. I'm much older now. And I thought about, well, just moving to a completely, I have been here before. I mean, I've been in 2006 and 7, each 1 month for research work here. So I knew what to expect. Well, I thought I knew what to expect. And yeah, that was more or less the way I came here. So it was for work, for university work.
Uh-huh. You are on a new job these days, is that correct or not?
Well, since 2016. In 2016, the JIST decided in the spirit of internationalization that they throw out all foreigners, besides those in the English department. That was especially very much welcome because in the very same month my daughter was born. So it was a good coincidence to go into unemployment in Japan with a newborn child. Yeah. And then after about 5 to 6 months, I joined the company in Tokyo in the research and development lab.
Mm-hmm.
And just this year in February, I changed to Fujitsu Research. That's very recent.
Can you tell us? I mean, do you apply logics in there? Is it complete separate parts of your lives as well? Or?
Well, in the previous company, it was more or less completely separate. I mean, nowadays what I do a lot is machine learning, right? Like most people. So there is not much logic there. Now, within Fujitsu Research, I'm working on neurosymbolic AI. So this is something where my logic background and, well, TCS background is hopefully merged with work in machine learning. So that's.
So does Fujitsu support basic research or is it fully applied?
Well, basic research. I would say they want, of course, a return of investment, right? In some sense. No, they do. I mean, they support a lot of research in a lot of areas. So really also basic research. Of course, you have to always argue, but I know several people doing this. Actually, from February when I joined till end of March, Fujitsu Research was a separate company. It was like only for research.
Mm-hmm.
And it was just merged. Everything is rebuilt currently in Fujitsu, so it was merged into the main company directly under the top officials. But yeah, basically it's the same. There is a lot of research going on. Of course, I mean, it's company research. You cannot expect doing whatever completely esoteric things. You have to at least explain why it is useful for Fujitsu, right?
Mm-hmm.
And the stuff I do since 30 years, my research, my personal, I just continue in my private time.
Are they still heavy on computing and
yes?
I remember, when I started my computing life, and my first laptop was a Fujitsu laptop, and I would only go with Fujitsu. And I don't see them in the market these days, but
they are still in the market with hardware. But well, it's of course so within Japan, but also in Europe, in several places, there are big companies who only work with Fujitsu machines. There is a lot of service, especially public service, so from the state, from the government, from local governments, where Fujitsu is very strong here. So yes, it's still a big company. I mean.
Mm-hmm. Cool.
Worldwide, like in America, Europe, so they have so parts are in Sunnyvale, in Madrid, and in London, and a few more places in Asia, I guess.
So let me change directions a little bit and ask you about something that always intrigued me. You seem to have a lot of interests in other open source material. I mean,
not only open source.
Let it put aside mountaineering. Let's put aside mountaineering, and which we can enjoy by going over to your blogs and your website and so forth, and see pictures of stuff that I will never be able to visit in my own lives. But they're amazing to see. But you seem to have a lot of interest in open source software outside tech.
Yes.
where does that come from? Is it a political? Is it?
Good question. Most of the time, I guess, I come around these projects because I'm not content with the current state and I want to fix it. And that simply works with open source quite nicely. And it doesn't work well with any other source. So that is most of the time one of the big driving forces of me getting into something. So, for example, one of the recent projects is this smart speaker. With FOSS Asia, we're developing a privacy-aware smart speaker and personal assistant. That's software that runs on a Raspberry. You can talk to it, you get answers without Google or Amazon registering everything. It's just because I'm so fed up with Google and Amazon because they're so stupid. I have devices in every room, more or less, because my wife likes to talk to them and my daughter and get music back. Most of the time it doesn't work out. So there are things I want to fix, and then open source projects are nice, right? And yeah.
So there is a personal need for to make something work, and there is also because I sometimes stop by your blog and your webpage, and when I see the description of the projects you're involved with, I get tired only from reading them. So long it is, and so long.
Yeah, but for example, the biggest one I recently got involved is the KDE Plasma desktop for Debian, because I was so fed up because in Debian it was horrible old, it was completely outdated, and nobody did the work. And I mean, it was like 2 years back and it wasn't really working. So I said, well, then I do it myself, right? And I did it first all myself, without the team outside of Debian, just for my own. I made all the packages, this 300, 400 package, all for my own. And because I wanted to have an up-to-date, recent, properly working system. And then other people started to use it, and well, it took 2 years, and now, well, hopefully it's now much better shape in Debian. So that was a lot of time I took last, but it's most of the time that I'm just not content with the current state that I start to fix things then.
But tell me one thing. How do you juggle this all? Do you get home and work until midnight
no, no, I normally get up at 3 or 4 o'clock in the morning.
And how do you find time? How do you, for example, tell me how many hours you put in on Tech Live, for example, every week?
On Tech Live, not that many anymore. It is, I mean, there were huge peaks in 2017, 18, 19. But since then, it has steadily decreased, like what is necessary. I mean, bug reports are getting less and less. Also, new feature requests are getting less and less, right? So there is not so much to do anymore. The daily grind work of updating packages is mostly done by Carl, unless Carl is on holiday or somewhere, then I do it. But I mean, also this is mostly automatized. So things we are doing, Carl and me, is more or less trying to get everything work as far as possible automatically, because at the end it's just a lot of repetition. And so we try to, I mean, it's just emergency fixing for problems. Like, when was it recently? 2 weeks ago, when the GNU-PG key again expired and one part wasn't updated. And so these are the things I wouldn't say that I put in Tech Live more than 3 to 5 hours a week currently. That would be a lot, actually, I guess.
So you consider it to be in steady maintenance mode right now? Yes.
At the moment, I mean, there are several things I started working on, but I never could convince myself to finish it within the Tech Live. Also because there was never the need for it. Yeah, so that's, I would say, the current. So as I said, I mean, Carl puts much more work in it, right? I mean, the daily update of packages is mostly all due to his work.
which involves taking the package and installing the package and
yes.
well, this is a lot of things.
Well, this is also 95% automatized, right? I mean, we have written several scripts that automatize all these updates and unpacking and repackaging and running LaTeX and everything, so that at the end, a package for TDS, Tech Directory Standard, comes out. But this is like mostly, it needs a big work for new packages or very special packages, but this has to be only once done for new packages and not permanently. So it works quite nicely at the moment.
Wow.
I think we got a guest.
I got a beautiful girl over there. Who is she? What's your name? What is your name? Can you tell me your name? Huh?
She's Haru.
Haru. Wow. What a beautiful name. How old are you?
Well, yes, say.
Oh, five. That's nice. Nice.
Say bye-bye. Bye-bye, you.
Bye.
Shuriken mottete. So that is standard nowadays, even with company meetings. That is little. No, Hannah, onegai.
Oh, it's beautiful. Beautiful that one can integrate this way.
Well, it sounds beautiful, but in reality, sometimes I wish I could go to an office, because concentrated work is harder when you. That's the reason what I told you before. I get up at 3 or 4 o'clock in the morning, because then I have at least 3 to 4 hours of peaceful work.
Yeah, but how long do you take to commute to work and commute back?
I don't commute since 2016. I'm fully remote.
Fully remote.
Fully since 2016, so long before Corona. So
long
even in my
Corona.
previous, because my previous company was in Tokyo, and I'm not in Tokyo, so I don't want to move to Tokyo. I'm actually on the other side of the island. So with the previous company, I visited the company like Hana onegai. Ne, ima dame. So with the previous company, I went once, twice a month for Tokyo. And now with Fujitsu, I would normally also go once, twice to Tokyo. But I mean, with Corona, everything is shut down, no traveling. So,
so it's unimaginable that the Tokyo subways and metro are empty or not being used at the moment, but
they are used, of course. They are completely filled, of course. I mean, they are not full. Well, completely full. I don't know, but I guess many people still have to go to work.
Cool. So since our conversation depended over to programming and tech live and so forth, I mean, what can we expect? Can we expect coming down soon? What can we expect down the year?
I think nothing considerable changes. No considerable changes in the next years. I think the biggest change over the next at some point in the future will be looking at 64-bit Windows, I guess. That is something I tried to support, but I gave up because it's too much. And so that would be something that lots of people are asking for, and within the Japanese community, actually, this is quite because due to the large fonts of often 32-bit Windows just runs out of memory. So there seems to be a problem with huge CIT indexed fonts. So especially if you load several, I mean, of them for different stuff. So there is some need for this. That might be something that comes in the future at some point. We don't know actually how. Maybe we just drop 32-bit and only work with 64. But I mean, there are a lot of people who still say that they want to keep 32-bit. And the problem is really, I mean, that is hard work. I mean, the most painful part of the code are the special cases for Windows. And duplicating and making this work for 32 and 64-bit platform from Windows is a challenge. And I think I've started 3 or 4 times. I have still branches in my Git repository somewhere, but they never realized. Also because I have, well, with Fujitsu, I started to have to use Windows nowadays, but I myself, I hardly don't use Windows. It's hard for me also to test things.
Well, I mean, since we got into the subject, let me ask you another question. So the Gartner Group estimates that more than 80% of the world shipping of operating systems right now do not run TAC. A situation which is
Gartner said this? Really? Wow.
Yeah, I mean, this is like 15 years ago, we didn't have Android, we didn't have iOS.
But we have TAC running on Android. That's not the problem, right?
Well, we do have some sort of TAC running on Android, which is
it's not integrated at the level you would like to see it. I agree, but
it's not TAC live. That's what I want to see. But that's something.
Well, actually, there is some Chinese don't they have some application, something where they actually, I'm not sure. Well, the problem is with the security obligation of this. I mean, it's actually getting more and more complicated, even on Macs. I remember 1.5 years ago, it was a discussion: can we actually install TAC Live going further, because Apple removes interpreters, locks down installation. It's getting harder and harder. I mean, if people want to use hampered and devices controlled by big companies, then please go ahead, yes. But it's getting more and more difficult by volunteers to support this.
But do you see a time that it's going to be difficult to acquire a machine that you'll be able to install, an operating system on it and be running with?
No, you can always install Linux, right?
Well, as I said, the situation in 15 years ago was such that every single operating system that was shipped in 2000, 15 years ago, every single operating system shipped ran TAC. And with iOS and Android, the situation is such that they kind of run TAC, but it's not the kind of TAC you want to use. And so it's if you really with a tablet, on the couch, and you want to do some TAC.
Yes, I completely agree. I mean, but that, I think, in principle is a question of developing a nice user interface. I think with Android, at least maybe, I'm not sure. I use Android, but I'm just a dummy user. But I guess with a rooted device, you can do everything. The question is how to interface with that, right? You want an application where you can just type, you can run. I mean, you want to Emacs, right? On your tablet, right? Well, not the whole Emacs, but what you want is you want to edit and kick off compilation from the edit screen and automatically switch to a PDF viewer. Yes, that would be nice, right? But that is something an Android application developer has to provide, right? This is not something. I think the actual code, the binaries, are something you can compile on Android. I think there are several projects compiling it for Android, and iOS should be also. I mean, we have binaries for Mac OS, and so it's not easy compiling for a different hardware architecture. It's not that trivial, especially with with Apple just throwing blocks at the developers. But in principle, this should be possible, right? It's just who is doing it, right? I mean, it's the lack of expertise, right? We had some people who could do this, but I mean, they also have their private life or whatever. As long as nobody steps forward and say, okay, I know Android, I can develop an Android, and I'm also pro open source. I'm writing an Android application that I don't sell and or just offer, then it won't happen. Always like this, you have to have the interest and fix it yourself, right?
Right.
What I said
before.
So,
I guess so. Yeah. There's somebody said that if you want something done, you should do it yourself. I don't know exactly who said that.
And since my phone is small, I won't run Android on it because typing on this is anyway a pain with my clumsy fingers. So in talking about that, which puts me on a parallel track, is there anything that you think it should be done with the TechLive on the distribution streams, if you run TechLive from Ubuntu, you get something which is like 5 years old, and if you get TechLive from Solaris, it's 12 years old. And so okay, now there are a few things that would be great. So the biggest problem at the moment is that packages are stupid, unfortunately, we have to say. There are too many, and I'm allowed to say this because I'm also a packager, right?
Okay.
And I answer all the questions on the Tell Distro list about how packaging. So the problem is most of the packages are not really users of, as I've seen this often, not users of TechLive. They just want to package it without really understanding how stuff works. I agree, this is complicated then and leads to disasters we have seen too many times. I also agree that the installation of TechLive is not trivial. It could be, so why? Because everyone is expecting configure, make install, ready, right?
Right.
That is what a lot of people are expecting and whatever. I mean, it could be CMake and then make or whatever. So there are a lot of options. So there we are far away from that. That is something, I mean, the compilation, the binaries, that can be made like this, but then a lot of handwork, I mean, not a lot of handwork, but a lot of stuff. I mean, you have to merge the main tree with the build binaries, then you have to link some binaries. And so it's not completely trivial. That would be something that would help, and that has been requested a few times, that would help packages and distributors to be more up to date, easier to include. Of course, there was the proposal from some in the group to switch to a different build system, like whatever, Ninja or CMake, which is a nice idea, but nobody has ever come up with an actual replacement of the current system. So that it's also a problem that the build system was written by Peter, who unfortunately passed away. So we have a serious lack of, because none of us, I mean, I can do AutoConf, and Carl, of course, is a AutoConf guru, but none of us, I mean, this build system is quite involved. So yes, there are some things for distributors that can be improved. I agree. There is, if I would have time, energy and interest, but for Debian, I know how to package it myself, right? And and for the others, I mean, I cannot care for others; they have to learn. It would be nice if you provide an easier way, like make, configure, make, install, and everything works. That would be nice. The problem is often with the splitting of into, because it's so big, right? I mean, they are now at several gigabyte, and most distributions split it at some whatever borders, right? And the problem is then if you split it, you have to take care for whether formats and font map files are properly installed or not, or activated. And if they are activated but not available, then you get errors. And these are the stuff. I actually talked about this, I don't know, during FOSDEM or something, how to package it. Yes, I agree. There are things. The problem is that the text system as a whole is, the whole packaging is, not the whole packaging, the whole way how things work is quite old. This format util conf and update make conf. Over the last 5 years, I have worked that we can use multiple of them, which makes it already much easier for distributions to ship file and users to add additional fonts and this kind of stuff. It still isn't perfect and it doesn't work for all kind of settings. So there are things to do to make it easier for distributors. But for example, if you say Ubuntu is not that far behind. The problem is with the release schedule of Ubuntu and TUG Live. Also the release schedule of Ubuntu Debian on TUG Live doesn't line up. And that means there's always at least 1 year behind.
Yeah.
But 1 year behind, it's often only the binaries and what they say, right? In Debian, for example, we did the last checkout from the CTAN, also from the Telnet in, I think, December, right? And that it was going into Bullseye. So the status of December 2020 is going into the next release. That was more or less the last cutoff date before the freeze, right? So it's not that old. Of course, well, then there are 2 years where this distribution is frozen more or less, and then you cannot update beside critically. But on the other hand, now be honest, most people only have update DTs, right? They want to get updates every day. It's not that they need it. I guess 99% of the tech documents run even on a 5-year-old TUG Live installation, is my guess.
That's correct.
Right?
That's correct. That's correct.
So it's just, why do I have TUG Live 2019 in Ubuntu? No, it's so old, and then they want something new. Not that it's really needed for them, right? But okay.
Well, I'll tell you something. This interview is not me interviewing myself, but I'll tell you something. An area that does require, update of all the binaries. We have we're working with with submissions by people that are submitting to a proceedings of a conference. And working on continuous submission so that they deposit their files on Dropbox and they write their books and write their papers on Dropbox or on Overleaf. And on Overleaf is not a problem. They write it completely within Overleaf and we use the Overleaf environment. But, for people which prefer to use their own tech on their own boxes on using Dropbox, for example, the very big problem, initial problem, we tell them, you have to update Bibliotech to the latest Bibliotech. Otherwise,
Well, that's true. You're completely right. Of course, there are some areas, Bibliotech Biber is one, where you want newer versions. I agree completely, right? But honestly, I write also a lot of TUG code, but I still haven't used BibLaTeX for any of my documents, right? So
you should. You should.
Yes, but I have all stuff in a bit.bib file, and I'm just too lazy to start using it because it works in any way. So.
All right. This was so nice. Tell me when we're going to see you again in person at Bahotech.
At Bahotech, well, that would be nice. But Bahotech is always when, I told you before, when there's one of the 3 holidays in Japan. This is this Golden Week, which means that it's one of the time when I can make holidays with the family. And so I would have to go.
This little girl can run everywhere. And
I would have to convince my wife that she wants to go once more to Bahotech. She was there once, right?
Right.
But for her, there is not so much sightseeing there, right, around Bahotech. And then there are a lot of freaks there.
That's right. Bringing a companion to Bahotech involves leaving them at Warsaw for a little while, so that they can have some fun at Warsaw.
Yes.
And then when they
Krakow,
exactly. I mean, I think this is the best way. This is the best way. Well, I miss you. I miss see you in person. I miss this nice
I miss
conversation.
traveling.
Yeah, but and hope to see you again soon.
Yeah, well, I don't know when the next conference is. I hope the next TUG will be in person. That would be the biggest chance, right?
Well, yeah, I mean, Context is planning a conference for next month in person in Belgium.
Yeah, there's no way. No way that I can go.
I don't have.
I hope that I can go in December to Europe. That would be my dream, but yeah. The problem is, I mean, Japan is quite strict with quarantine when you return from abroad. So that's. So, for example, you are not allowed from the airport, you're not allowed to take public transport home. And that means I have to drive a few hundred kilometers across the whole island to an airport, leave my car there and drive home myself. And then I have to stay at home for, I think, 10 days or 2 weeks without leaving. It's already better now, because before you had to stay in a government decided hotel without leaving the room for 10 days. Yes. Now imagine being with a 5-year-old daughter locked in a room without. That would be quite funny.
Well, but the conditions in Japan are extreme. You know, the island is small, the population is huge. Cities like Tokyo are humongous, and so it does need some, pretty tight controls. Otherwise, things will. I mean, you see what happens in Brazil and what happened in India when you don't control.
Yeah. Now I'll see. Let's hope. In December, I hope to can go to Europe, and then Pachodech would be really nice. I mean, yes,
yeah.
My morning coffee is most of the time in this cup.
All right. Hope to see you there.
Thanks a lot.
Thank you, and enjoy a lot the conversation. And we're gonna continue this at some time.
Yes, sure enough. Also on the social platform which we are using anytime.
Yes.
Okay.
Yes. Thank you very much.
Thanks for your time. Bye.
Bye.